All right, so this is pre-algebra lesson 8-1, and it's actually part 2 of the lesson titled Functions. And just to review a little bit yesterday, remember we learned about an independent variable and a dependent variable. The independent is the one that acts on its own. The values are chosen and don't depend on the variable. So the independent is the input. It's nice, they both start with I. The dependent variable, it depends on the input. So that's the output. Depends on what you put in. We also talked about the definition of a function. And remember, it's a relation where each element of the domain is paired with exactly one element of the range. So you can't have two y's that are matched with the same x. And then we had situations where you had to determine if it was a function or not. And ones that were in ordered pairs, sometimes it's in a table. We learned the vertical line test, and remember that's where you can look at the graph, and if it has any place where a vertical line going up and down, if it touches more than one point with each line, then it fails. It's not a function. So those are different ways to tell if it's a function. So today I want to add to that, and we're going to look at how we can take a function and write it, if it's in an equation form, and we write it in a certain notation called function notation. So we're going to take an equation like y equals 2x plus 3 and convert it to what's called function notation. Then we're going to take that notation, we're going to learn what it means, how to evaluate for different inputs, and then we're going to also look at some real-world problems, some word problems, and practice writing them a little bit. We'll do a little bit of that. So let's start out. So an equation would be when you have your x and your y. So an example would be y equals 2x plus 3. And then when you change it into what we call function notation, all you do is you change it to, instead of the y, you say what your input is, and it's f for function, and then in parentheses you put an x because that's your input. And these parentheses are not indicating multiplication. This doesn't mean you multiply a variable f times x. It's read that you have one thing as a function of another. So this would see f of x. That's how we'd read that. F of x. It's as a function of x. And then you'd equals 2x plus 3. And it looks a little weird. It's not something you've seen before. But that is the same equation. It's just written in what we call this function notation. So notice instead of the y, you write f of x. That's how that's you say it, f of x. So it means it's a function of x, saying that's what your inputs are. So if you were to take y equals negative 3x plus 4, that's the equation form. If we change it to function notation, why don't you try it? Okay, so instead of the y, you just put f of x. It's a function of x equals negative 3x plus 4. So that's what that means. Well, we can take something that's in function notation. So if you see something like f of x is equal to 4x minus 7. That's the function notation. And so then it might say to find the value of f of 5. And so that's saying this is your function, f of x. Instead of x, we want to plug in 5. So we find our function, and it says 4. We want to multiply 4 times our x, our input. And so our input is 5. So notice right here, I'm just taking the x instead. This tells me what the x is equal to, and I plug it in place of my x, and then I just simplify. So 20 minus 7, and we get 13. So in this case, f of 5 is equal to 13. Okay, let's use our same function. In this case, let's find f of, let's do -2. So that's saying I want f of -2 to go into this function. So my function says to multiply x by 4, and my x, remember, is -2, and then subtract 7. Again, I'm going back to this function and just plugging it in. So then I simplify. 4 times -2 is -8. And I have subtraction. Remember, we rewrite it as addition. You add the opposite. So we get -15. So f of -2 is equal to -15. All right, you try. Find f of -4. Evaluate. It said find the value of the function if x is equal to -4. So I'll wait a second here while you try it. Okay, so we go back to our function. F of x is equal to 4x. So in this case, we want x to be -4 minus 7. So we simplify it. That'd be -16 minus 7. Make it plus a negative, and we get -23. So f of -4 is equal to -23. All right, let's try another one. This will be our number 2. And so let's say if f of x is equal to 14 plus 3x, find, now notice it's not the same function anymore. Before it was f of x equals 4x minus 7. Now it's a different equation, a different function, f of x equals 14 plus 3x. So if we are asked to find what's f of 4, that's saying plug the 4 into this function for x. So we have 14 plus, instead of 3x, we do 3 times 4. It's your order of operations, 14 plus 12, so we get 26. That's what f of 4 is. Okay, we'll call that A. Let's do B. Let's find f of -7. You try it. Use this function. Okay, so go back up to what the function is given. It says 14 plus 3 times x, so 3 times -7 equals 14 plus a -21. We have different signs, so we find the difference, and the negatives win by 7. So it turned out that f of -7 is equal to -7. So that's how you would use function notation. You can evaluate it for different values of x, and you plug it in. Now you could even have something with a different, well, maybe I won't show you that. I don't want to confuse you. Let's go ahead and start to look at it in a real-world situation. Because a function, right now we're doing it as a function of x, and we're using that in place of our y. But a function can also describe the relationship between two quantities that are actual things, like the distance you travel in a car depends on how long you're driving. You go more distance the longer you drive. So in other words, distance is a function of time. So let's write that down, and because this is a common situation that you'll see. Distance is a function of time, meaning the distance is determined by how long, the time that you're driving, the time that you're traveling. And so the way to write that in function notation, distance as a function of time. And so your d for distance, a function of, and then your time. So whatever it's a function of, that's your input. That's what goes inside your parentheses. So keep that in mind, and let's try this next problem here. I want you to write down the situation. So we've got a girl named Melissa, and she spent $19.35 downloading songs to her iPod. From iTunes. We don't have to write that down. 4, we need to tell how much she paid for each song. For $1.29 each. So each song cost her $1.29. And the first part is you're going to be asked to use function notation. So use what we've just been talking about to write a function that gives the total cost as a function, remember that phrase over here, as a function of, that's going to be key, the number of songs purchased. So use function notation to write a function that gives the total cost, so we've got cost, as a function of the number of songs purchased. And notice here, as a function of. That's going to be a real key thing. And then the second part, it'll say to use the function that you just wrote. Use the function to determine the number of songs she downloaded. Okay, so let's go back to part A. So we've got cost as a function of the songs. So cost as a function of the number of songs. And you can see our variables there starting to, hopefully you're starting to see them, the cost as a function of the songs. So let's do C for cost, S for songs. So how would I write that as in that function notation like we did before, the f of x, or we did distance as a function of time, d of t? What do you think that's going to be? Cost as a function of songs. Which one's the input? What's the independent variable that you put in? The songs. The number of songs is independent. That determines the cost. So the cost would be the dependent one. It depends on how many songs you buy will determine your cost. So we'll do C as a function of S, meaning the cost as a function of the number of songs. So then what do we do to find out how much her cost is? What do we do to the input, the S? Well, it said that they cost $1.29 each. So what does that mean, each? Do we add, subtract, multiply, divide by $1.29? Well, every song has to be multiplied by $1.29, and make your S look like an S, not a 5 there. So there's your function. Cost as a function of the songs, the cost is equal to $1.29 times the number of songs. Okay, so then that's part A. That's what they're looking for, this function. Use the function now, cost as a function of songs equals $1.29s, to determine the number of songs she downloaded. Well, let's go back. What piece of information have we not used from the very beginning? Well, it says up here that she spent $19.35. That's her cost as a function of songs. That's how much she pays. So let's plug that in. That's $19.35. Now, and notice we put that in for this whole thing because remember that was really our Y before. That was our output. The cost as a function of the songs is the output. That's how much it costs. So that goes in for this whole thing. Equals $1.29s. And then we just solve this equation. Divide both sides by $1.29. And you guys don't need to use calculators on this. You can actually divide it out. So you'd have your $19.35 divided by $1.29. Remember what you have to do when you're dividing by a decimal? Move it over to make it a whole number. So in this case, we'll move it over twice. And if you multiply it out, I believe, let's see, this will go in there once, 129. We'll subtract 8, so that'd be a 6. Bring down your 5. Whoops, change colors. 5 times 9, 45. We get 645. So the number of songs, S, is equal to 15 by plugging that in. Okay, so that's one. I want you to try one. Let me clear this off. I want you to get a textbook out and open up to page 397. So go ahead and do that. If you guys need to pause the video a minute so everybody can go get their book, go ahead and do that. We will be looking at number 4 about whales. And that's in that guided practice in the middle of the page. And once everybody's ready, we'll read it. And this one's going to be really similar. We're going to model it after the one we did about the songs. So it says, a whale watching boat traveled at a speed of 5.5 miles per hour. Use function notation to write a function that gives the total distance traveled as a function of the time in hours spent whale watching. Okay, so did you catch that phrase? Let's actually write that down to help us. It says write a function that gives the total distance traveled as a function of, there's that phrase, distance as a function of the time in hours spent whale watching. There's that distance as a function of time like we did earlier. So that should seem very familiar now. So we'll do D for distance, T for time. So remember earlier we did distance as a function of time. And then we need to write down, well, what do we do to the time? Remember, time is our input. That's the independent variable. So we look back. The first sentence there, it said a whale watching boat traveled at a speed of how much? 5.5 miles per hour. So that's 5.5 miles for every hour. So for every hour, there's your time, you need to multiply by 5.5. Every hour you go, you're going to travel, it'll travel for 5.5 miles. So there's your function. Hopefully we've done some of that, so hopefully that does make sense. So there's your function notation for this situation. So distance as a function of time, you get your distance when you multiply your time by 5.5. All right, part B, use the function that you just wrote to find how long it took to travel 25 miles. So that's really saying distance as a function of, well, 25 miles. And, oops, I need to actually change that, because it gave us our distance, the amount of distance we went. So that actually is like the other one. We'll plug that in. 25 miles is our distance. But it said we want to find how long. We don't know the time. So 5.5 t. Alright, so we'll solve both sides by solve for t, divide both sides by 5.5. Cross that out. We'll divide 5.5 into 25. Have to move that decimal over 1. So it becomes 55 into 250. And we'll 4 times, let's see, that would be 220. We have to add a decimal and a 0. Bring that decimal up, running out of room. Let's try 5. Okay. Let's see what that's working out to be. Yeah, I thought it was going to stop, but it looks like it's not. So we're just going to estimate it at 4.5. Because as you notice, it's not stopping there. So the next number is going to be another 4, because you're going to get 25, and then you bring down your 0, 250. So let's just put it as 4.5 hours. Okay? All right, here's what I'd like you guys to do here in class. I want you to get your workbooks that are in that back cabinet next to the textbooks in the back. Remember, your name's on the bottom of the binding. You can get your workbooks, and in the workbook, you can do this. You don't need to do it in your spiral. Just do it in there. I want you to turn to page 95 and do that page, numbers 1 to 24. So work those out. If you're quiet and you want to work with a partner, that's fine, as long as you're working quietly. And so while you're working, you guys can stop this video. Once everybody's finished, then I'll start it back up, because I'll show you the answers. You guys can check them. And then once you've checked them, corrected them, then you can go ahead and start on tonight's homework. Okay, so here are your answers. And notice, you probably realized as you were doing them that the first part is reviewing what you did in part 1 of this lesson, and then this later part of it is doing what we did today. So there you go. You can pause it here and get all your answers checked, and then when you've finished with that and you've corrected them, you can start on your homework.